Good morning or afternoon or whenever you're watching this. So, we're going to continue our last discussion, which was about logarithms, but we're going to do it just with two skills. I was trying to figure out what I think is the most important for you guys when it comes to what you're doing on like an ACT test or whatever math class you're coming into next, or maybe a science class you have to take. And really, there's just two main skills. One's calculator based, one is more kind of understanding the form. And we're going to go through those two. I will show you the calculator piece. That's actually the second half. And then your assignment will be to review just those two skills. So the first skill that I want to review is actually more of a continuation of what we did last time, which is how do we write logarithms as exponents or exponents as logarithms? Because that's all a logarithm really is it's another way to write an exponential equation or an exponential function. So our first skill is, can you go what I call form to form? So our two forms are logarithm form, which obviously has log in it, so they're really easy to identify, and then exponent form, which again has an exponent, so it's easy to identify. So here's how we transition. I put this kind of up in the corner. This might be something you want to take a picture of, do a quick screenshot, because this is how the two forms kind of work together. I call it like a circular pattern. Some people call it like a cloud pattern. It rotates around. When you have a logarithm, your base number, which we call b, your base number is going to be written to this power. So whatever value is over here is actually your exponent. And that's going to equal this number that I always call the big number because there really isn't a name for it. So this is your log form, and then this is the exponent form that goes with it. So your base b to the y power equals x. So that's how we transition. So I want to take you through two examples each, going from one form to the next, and then I'm going to use my whiteboard so you can actually see them happen in real time and not just look at a piece of paper in front of you or on the screen in front of you. So here's your logarithm form. Log base 2 of 8 equals 3. To write that as an exponent, we always start with our base number. That's kind of where we originate this pattern. 2 to the third power equals 8. So here's your exponent form that matches it. 2 is your base. It's your base of your logarithm. It's your base of your exponent. 3 is your exponent, and then it equals 8. Same thing here. This one has a base number that's a fraction. There is really not much limitation on your base numbers. You can have fractions. You can have decimals. So what we're saying with this, log base 1/2 of 1/16 equals 4. To write it as an exponent, you're going to start with the base number. So 1/2 to the fourth power equals 1/16. So here's what I just said. When I have fractions, it does help to use parentheses. So 1/2 is your base, 4 is your exponent, and then it equals your big number, 1/16. Going the other way, sometimes this one feels a little more awkward. Going the other way would be a situation where I would actually give you the exponent notation. So 5 to the third equals 125. We know that to be a true statement. To turn that around and go to log form, your base number 5 is going to be the base number of the logarithm. So when you have base 5 here, you're going to put a little 5 here as your base number. Your answer over here, the 125, is going to be the big number. And then your exponent is the answer in a logarithm statement. So the 3 goes here, the 5 goes here, and the 125 goes here. Looking at this one, kind of doing the same thing, 8 to the negative 2 power. We know negatives, exponents move things to the denominator, equals 1/64. So your base 8 is going to be the base of the logarithm. Your 1/64 is going to be the big number of the logarithm. And then it's going to equal the exponent in the statement. So negative 2 is going to be what's on the other side of the equal sign. So sometimes it helps to see them in actual real time. So let me get my board. Let me grab a marker. So here's what you're going to be asked to do. You're going to be given a logarithm statement. And it's going to be a true logarithm statement. It's not something that you actually have to figure out. Log base 3 of 81 really is 4. Your directions are going to be to come up with the correct exponent notation. So when you're doing this, you want to start with your base number, 3, take it to the fourth power, and set that equal to 81. So the correct statement would be 3 to the fourth power equals 81. And it should be a true statement. We know the logarithm is a true statement. The exponent notation should be a true statement. Going the other way, get rid of this and show you a exponent to logarithm notation. You're going to be given a true exponent statement. So here's a true exponent notation. 7 to the negative 2 power equals 1/49. And then the directions will ask you to identify the logarithm statement that can be written. So your 7 is your base number. So that means when I write log, I'm going to put a 7 as my base number. The 1/49th is going to go next. That's your big number. And then your answer in the logarithm statement is going to be the exponent. So negative 2 is going to be on the other side of the equal sign. So that's the first skill you should be comfortable with. Second skill is going to be doing something that's a little more calculator driven. It's something called the change of base formula. So the change of base formula is a formula probably used more in a science class when you're asked to evaluate a logarithm and it's not something you can figure out in your head. It's not something you can guess and check. It's something that you are going to look at and say, I just don't know the answer. On a graphing calculator, there are some buried ways to evaluate logarithms that you struggle with, but they're hard to get to. So this is a much easier way to utilize your calculator to figure out logs. So the change of base formula allows you to take a log that you can't figure out how to get an answer and you can't use a button on your calculator, and it converts it to something that you can do on your calculator. So here's the formula, and this is another nice thing to take a little picture of. It says that if you have log, we're just calling the base c of some number u, and I'm trying to figure out what that is. Change of base formula says to evaluate it, you can take the common log is a button on your calculator, it's base 10, of the big number divided by the common log of the base number. And that will give you your answer. And you're going to get a lot of decimals for these. Or if you don't want to use the common log button, you could use the natural log button. So the button that says ln, you're going to do the same pattern. You're going to take the natural log of the big number divided by the natural log of the base number. And that will give you your answer. So I have some examples down here. I have one that I actually made a mistake in, but I'm kind of glad because it allows me to illustrate a common mistake. Two issues with these students have is parentheses or putting things in the wrong location. So let's say you're asked to find the log base 3 of 15, and it's not something you can do in your head because what this is saying is 3 to what power equals 15. And we know 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, but you're never going to get 15. So the way that we use this formula is you're going to take the log of the big number, I did common first, log of 15, and then divide it by the log of the base number. Now, when you put it in your calculator, you're going to type in your common log. Let me get rid of all this mess that I have here. You're going to type in common log of 15. You have to close your parentheses. That is the most important button here. And then you're going to hit divided by your common log of your base number 3. You don't have to close parentheses here. You can if you want. And you're going to get about 2.46. I'm going to ask you to go 2 decimal places for me. The next one wanted to know log base 5 of 82. Again, not something you could do in your head. So this one I did with natural log. I actually like the natural log button a little bit better. To me, I use it more in my other classes and it's a little shorter to write. So I'm going to type in my natural log of my big number, 82, close your parentheses, and then divide by the natural log of your base number, 5. You can close parentheses, you don't have to. And again, you get a decimal, you get about 2.7, it's going to round up to 2.74. So the other mistake that I want to make sure you don't make, and I actually did it, I wasn't intending to it, but I left it because I liked it, is you can accidentally use 2 different logs. So you have your choice. You can use common log, you can use natural log. You can't combine them. So if you choose to use natural log, you got to use it the whole time. So here's where I messed up, and I'm going to show you how to fix it. I need to figure out log base 4 of 1/24th, and I started to use common log, but then halfway through switched to natural log. I can't do that. I have to pick. So I'm going to do this one with common log. So I'm going to type in my common log of 1 divided by 24 and close parentheses. And then I need to divide by your common log again. You can't switch to natural log, and that's where I messed up, of 4. And you get negative 2. I actually typed it in right in my calculator. I wrote it wrong. You get negative 2.29. And then the last one, I went back to natural log here. Again, I kind of like that the most, but it really doesn't matter. So I want to figure out log base 6 of 93. So I decided to do natural log of 93, the big number, close your parentheses, and then divided by the natural log of your base number 6. You do not have to close parentheses. And you get 2.5, it round up to 2.53. So that's how change of base formula works. You may need this in a science class. You may need this on the SAT or ACTs. And as long as you have a calculator close by, it allows you to evaluate any log. Even the ones you could do in your head, you could actually use your calculator as a backup plan. So 2 skills that you should be comfortable with and you should be able to show me you can do on the Google form. You should be able to go form to form, log to exponent, exponent to log, and you should be able to use the change of base formula to evaluate logs. Hope that makes sense. If you have any questions, let me know. Reach out. And I'm going to put a Google form assignment that follows this video to make sure that you do understand what I just talked about.